Okay, let me first refresh our memory on the idea of an inverse function, which we covered back in part 1 or 2 of this website. Just remember an inverse function. If we have some graph, we plug in, if this is y equals f of x, sine x or whatever, all right? Then when let's make it sine x, this is the sine graph. When I pick an x value and plug it in, out comes my y value, yeah? The inverse function is the function that when I plug in my y value, it takes me back to this x value, yeah? Now in the case of trig functions, the x-axis, these are angles, right? Pi over 2, pi, 3 pi over 2, those are the angles. So when I use my inverse function and plug a y value into my inverse, what's going to come out is an angle. In other words, the value, when I evaluate an inverse trig function, my y, the answer, is an angle. All right? Now another thing before I talk about this. If you remember, for inverse functions, they got to be 1-to-1 in order to have an inverse. The function has to be 1-to-1 to have an inverse. What is 1-to-1? It's got to pass the horizontal line test. Look at sine. A horizontal line crosses a whole lot of times. In order to pass the horizontal line test, it's only got to cross once. So what we do here is we only consider the part of the sine graph that is 1-to-1. And if I only look at this part and this part of the sine graph from here to here, this is 1-to-1. So that's the reason why, in order to maintain our 1-to-1 criteria that we need for an inverse, our angle, our answer, has to be between negative pi over 2 and pi over 2. All right. What about inverse cosine? So this is the notation that says y is the inverse sine of x. It's the same thing as saying x equals the sine of y. I'll explain why that works in a second. Similarly, look for inverse cosine. Y is the inverse cosine of x. That's the same thing as x is the cosine of y. But again, it's got to be 1-to-1. In order to be 1-to-1, where do we need to restrict our angle to? Well, here's our cosine graph. And we want it to be 1-to-1. So notice if I chop off, or don't only consider this part of the graph, this part of the graph of cosine is 1-to-1 because it passes the horizontal line test. So this is saying our answer, when we evaluate an inverse trig function, the answer, the y value, has to be between 0 and pi. Okay, now why is this the same thing as this? Look at this. Maybe before I do that, remember, if I take the inverse of f of x, which we learned about inverse functions, this is nothing more than x. Yeah? All right. So let's consider this equation here. Well, remember, with an equation, we learned you can do anything to both sides, as long as you do it to both sides. Let's take the sine of both sides. Yeah. So the sine, if we'll take the sine, if this is true, then the sine of y equals the sine of the inverse sine of x. But like I just said, f of f inverse is just x. So this is x, and we get the sine of y equals x, which is the same thing as x equals the sine of y. So that's why these two things are saying the same thing. It comes from the same equation. So now what we'll do in the next videos, I'll do an example of evaluating an inverse sine function and an inverse cosine